See next question. Discuss the continuity of the function f where f is defined by f of x is equal to 3 if 0 less than or equal to x less than or equal to 1. F of x is equal to 4 if 1 less than x less than 3, and f of x is equal to 5 if 3 less than or equal to x less than or equal to 10. See here, function is constant function in these intervals, right? That is f of x is equal to 3 when x belongs to 0 to 1. Okay, and when x belongs to 1 to 3, function is 4. And where for x belongs to 3 to 10, open interval 3, 10. Okay, so in that case, function is f of x is equal to 5. That means function is a constant function, and we know that constant function is a continuous function. Therefore, we can say for this interval given function is continuous, right? That is, for x belongs to 0 to 1, x belongs to 1 to 3, and x belongs to 3 to 10, the given function is f of x is constant function, and hence it is continuous at x belongs to 0 to 1, x belongs to 1 to 3, x belongs to 3 to 10. Okay. Now here we have to check whether this function is continuous at x is equal to 1 and x is equal to 3. Okay, because our conditions are in, see, 0 less than or equal to x less than or equal to 1. Okay, the function is 3. And when 1 less than x less than 3, the function is 4. Here also, the 3 less than or equal to x less than or equal to 10. Here we have to check the left hand limit and right hand limit at x is equal to 3. Okay, x is equal to 3 and x is equal to 1. So let's check. Limit, first of all, at x is equal to 1. Okay, limit x tends to 1 minus f of x, that is equal to limit x tends to 1 minus f of x, that is 1 minus less than 1. Okay, so when x less than 1, the function is 3, so limit is 3. Okay, therefore next, limit x tends to 1 plus f of x, that is equal to limit x tends to 1 plus f of x, that is 1 plus means greater than 1. When x greater than 1, the function is 4. So limit value is 4. See, here we have got left hand limit not equal to right hand limit. Therefore, here itself we can say the function is not continuous at x is equal to 1. Okay, so here f of x is not continuous at x is equal to 1. Next, what about x is equal to 3? At x is equal to 3, let's find left hand limit and right hand limit of the function. Limit x tends to 3 minus f of x, that is equal to limit x tends to 3 minus, that is when less than 3, x less than 3, the function is 4, that is equal to 4. Next, limit x tends to 3 plus f of x, that is equal to limit x tends to 3 plus f of x is when x greater than 3, the function is 5. So limit is 5. See, here also we have got left hand limit is not equal to right hand limit. Hence, this function is not continuous at x is equal to 3 also. Okay. So here f of x is not continuous at x is equal to 3. Okay. So here we have to discuss the continuity of the function f. So here we can say the function, given function is not continuous at x is equal to 3, x is equal to 1 and x is equal to 3. Sorry. X is equal to 1 and x is equal to, at x is equal to 1 and at x is equal to 3, this function is discontinuous. Next 17th question, 15 and 16 you have to refer from question number 14. So 17th question, find the relationship between a and b so that the function f defined by f of x is equal to ax plus 1 if x less than or equal to 3, f of x is equal to bx plus 3 if x greater than 3 is continuous at x is equal to 3. Okay, so here it is given, if this function is continuous at x is equal to 3, then what is the value? What are the values of a and b? Okay, so we know that what are the conditions to become a function is continuous. Okay, so here f of x is equal to ax plus 1 if x less than or equal to 3. Okay, now here it is given this function is continuous at x is equal to 3, right? So let's find like a left hand limit and right hand limit. Okay, so that is limit x tends to 3 minus f of x, that is equal to limit x tends to 3 minus when x less than 3 the function is ax plus 1. Okay, that is equal to substitute x is equal to 3, that is 3a plus 1. Okay, next let's find right hand limit. Limit x tends to 3 plus f of x, that is equal to limit x tends to 3 plus when x greater than 3 the function is bx plus 3. Here also substitute x is equal to 3b plus 3. Okay, 3b plus 3. So next here, and what is the value of the function? F of 3. F of 3 means when x is equal to 3. When x is equal to 3, the function is ax plus 1. Okay, f of x is equal to ax plus 1 when x is equal to 3. So f of 3 is equal to 3a plus 1. Okay, so here no need to find this one. Okay, these are enough. So here equate these two because it is given that this function is continuous at x is equal to 3. So what is the value? What are the values of a and b? So we know that if it is continuous, this left hand limit and right hand limit of the function at x is equal to 3 are equal, right? So here that is limit x tends to 3 minus f of x, that is equal to limit x tends to 3 plus. Why? Because since f of x is continuous at x is equal to 3. Okay, since f of x is continuous at x is equal to 3, limit x tends to 3 minus f of x, that is equal to limit x tends to 3 plus f of x. That implies what is left hand limit? 3a plus 1, that is equal to 3b plus 1. That implies 1 cancelled and 3 also cancelled. So a is equal to b. So here not value. Okay, we have to find the relationship between the a and b. Okay, relationship between a and b. So the relationship between a and b is a is equal to b. Okay, when this function is continuous at x is equal to 3. For what value of lambda is the function defined by f of x is equal to lambda into x square minus 2x if x less than or equal to 0, f of x is equal to 4x plus 1 if x greater than 0, continuous at x is equal to 0. What about continuity at x is equal to 1? Two questions are here. Okay, so first one, if the function is continuous at x is equal to 0, what is the value of lambda? Okay, so that we have to find, and we know that if the function is continuous at x is equal to 0, the left hand limit and right hand limit of the function at x is equal to 0 are equal, right? So first of all, let's find the left hand limit and right hand limit. Okay, limit x tends to 0 minus f of x is equal to limit x tends to 0 minus means x less than 0. When x less than 0, the function is lambda into x square minus 2x. Okay, substitute x is equal to 0, 0 minus 0, 0, 0 into lambda 0. Okay, so next limit x tends to 0 plus f of x, that is equal to limit x tends to 0 plus, when x tends to 0 plus x is greater than 0, when x is greater than 0, the function is 4x plus 1. Here also substitute x is equal to 0, 1, right? See here we have got left hand limit, there is we have got left hand limit is 0, right? And right hand limit is equal to 1. There is no lambda terms, right? So here left hand limit is not equal to right hand limit for any value of lambda. Okay, so here we can write, we cannot equate this, right? So we limit x tends to 0 minus f of x not equal to limit x tends to 0 plus f of x for any value of lambda. Any value of lambda. Okay, that means there is no value of lambda to this function be continuous at x is equal to 0. Okay, so next question is, what about continuity at x is equal to 1? See, very easy. What about continuity at x is equal to 1? See, our conditions, x less than or equal to 0, when x is greater than 0, two functions are here. Okay, so when x is greater than 0, see, at x is equal to 1, at x is equal to 1 means x is greater than 0. 1 is, that is nothing but 1 is greater than 0, right? So here when x is equal to 1, that means if x is greater than 0, the function is 4x plus 1. So this 4x plus 1 is a polynomial function, right? And we know that polynomial function is always a continuous function, right? Therefore, this function is continuous at x is equal to 1, okay? So we can write at x is equal to 1, f of x is equal to 4x plus 1 is a polynomial function. Hence, f of x is continuous at x is equal to 1. Okay? F of x is continuous at x is equal to 1. Show that the function defined by g of x is equal to x minus greatest integer of x is discontinuous at all integral points. Here it denotes the greatest integer less than or equal to x. Okay, so here we have to prove this given function is discontinuous at all integral points. Okay, so if you take any integer, it should be discontinuous. So for that we have to prove taking any integer, and we have to prove the limit, left hand limit and right hand limit are not equal to 0 at that point. Okay, so here first of all let's take this one. Let's consider only this function, that is greatest integer of x. After that we will take it together. Okay, so here first of all let's take any integer. Okay, any integer. Let c be any integer. Okay, let c be any integer. Then let's find limit x tends to c minus greatest integer of x. So what is the limit x tends to c minus greatest integer of x? See, we know that what is greatest integer of x. This function defines, see, it is greatest integer less than or equal to x. Okay, suppose it is 6.8. So what is its value? 6, right? That is larger value but less than 6.8. Okay, larger value but less than 6.8. So that is 6. So here what about 9.19? Okay, so here see, let's consider 6 as a c. Okay, c is equal to 6 and x is 6.8. Okay, c 6 and x is 6.8. So c minus means what? X tends to c minus means the x value is close to c but less than c. That is x value close to 6 but less than 6. Here less than 6 means it may be 5.99 something. Okay, whatever. So what is the value of this one? That is nothing but 5. Right? Its greatest integer value is 5. Right? Okay. So here we have taken c as 6, right? Okay, c as 6 and x as 6.8. So we have got its value is 5. That is, limit extends to c minus greatest integer of x is equal to 5. Right? Because here c minus means less than c, right? Less than c, that means less than 6. Less than 6 means 5 point something, right? 5 point, it is very close to 6 but less than 6. That is 5.99 something. Okay. So whatever, the greatest integer value will be 5. Okay. So here we can write 5 is nothing but 6 minus 1, right? So here we can write c minus 1. Okay. So limit extends to c minus greatest integer of x is equal to c minus 1. Now what about limit extends to c plus greatest integer of x? Okay. For same example, let's take x is equal to 6.8 and c is 6. Okay. C plus means x greater than 6, right? That is, c plus means x greater than c. X greater than 6 means 6.00 or 6.1 or 6.2 something. So whatever the value, greatest integer of that value is 6, right? That is c. Okay. C itself. Next, okay, here we have got left hand limit and right hand limit of this greatest integer function. Now let's find it together. Okay. Limit x tends to c minus, our function is g of x, right? G of x, that is equal to limit x tends to c minus x minus greatest integer of x, that is equal to, okay, split the limit, okay? Limit x tends to c minus x minus limit x tends to c minus greatest integer of x, that is equal to, here limit, it is nothing but c. Okay, substitute x is equal to c, so it is c. Okay, minus limit x tends to c minus greatest integer of x is nothing but c minus 1. C minus 1. Then c minus c cancelled, so answer is 1. So next we will find right hand limit. Limit x tends to c plus g of x, that is equal to limit x tends to c plus x minus greatest integer of x. Okay, that is equal to limit x tends to c plus x minus limit x tends to c plus greatest integer of x, that is equal to, here substitute x is equal to c, so it will be c minus, it is nothing but c, so it is equal to 0. So we have got left hand limit is equal to 1 and right hand limit is equal to 0. They are not equal for this integer. That is, we have taken any integer. If we take any integer, we will get these two different left hand limit and right hand limit. Okay, for any integer, this left hand limit and right hand limit of the function not equal. Okay, therefore we can write this function is not continuous at all integral points. Okay, so here limit x tends to c minus g of x not equal to limit x tends to c plus g of x. Therefore, given function g of x is equal to x minus greatest integer of x is not continuous or discontinuous at all integral points. Is the function defined by f of x is equal to x square minus sin x plus 5 continuous at x is equal to pi? Okay, very simple question. So here there is no conditions, means no inequality, x less than x, like x less than x greater than. So here first of all we will find, we have, according to the definition of the continuous function, we have to prove, that is value of the function that should be is equal to limit of the function. Okay, that means limit x tends to pi f of x. Here no need to find left hand limit, right hand limit. Okay, we cannot find because it is there is no inequality like x less than x greater than. Okay, so directly we will find limit x tends to pi f of x, that is equal to limit x tends to pi x square minus sin x plus 5. That is equal to, substitute x is equal to pi. So pi square minus sin pi plus 5. What is sin pi? Is 0, right? That is sin pi is 0. So pi square plus 5. Now let's find value of the function f of pi. Okay. Here we have to check whether this function is continuous at x is equal to pi or not. Okay. So here next we will find the value of the function f of pi. F of pi is equal to, f of x is equal to this one. F of pi is nothing but replace x to pi. Okay. So pi square minus sin pi plus 5, that is equal to pi square plus 5. Okay. Therefore limit x tends to pi f of x, that is equal to f of pi, hence f of x is continuous at x is equal to pi. That's all. Discuss the continuity of the following functions. A, f of x is equal to sin x plus cos x. B, sin x minus cos x. F of x is equal to sin x into cos x. So here also let's find limit. Okay, for that here we have to check this continuous at function, right? Continuous function or not. Okay, whether this function is continuous or not. So here for that let's take any integer from the domain of this function. Okay, so here we know that domain of this function is R. Okay, so here let's take any integer. Let C be any integer. Okay, from the domain. Okay, then limit x tends to c f of x, that is equal to first one. Okay, a f of, in limit x tends to c, f of x is equal to limit x tends to c, f of x is sin x plus cos x. That is equal to, here substitute directly. Okay, sin c plus cos c, right? We will get sin c plus cos c, or you can take c is equal to, that is x is equal to c plus h, so that you will get limit h tends to 0. We have done this one. Okay, so limit x tends to c, sin x plus cos x, that is equal to sin c plus cos c. Okay, then next let's find f of c. F of c is nothing but f of x is sin x plus cos x, so f of c is sin c plus cos c. So here we have got limit x tends to c, f of x, that is equal to f of c. Okay, so according to the definition of the continuous function, we can say this function f of x is equal to sin x plus cos x is continuous. F of x is equal to sin x plus cos x is continuous. So similarly, you can check the continuity of remaining these two functions also. Okay. Find all points of discontinuity of f where f of x is equal to sin x by x if x less than 0, f of x is equal to x plus 1 if x greater than or equal to 0. Very important question. And here, okay, we have to find at what points the function is discontinuous. Okay, so here, see, for x less than 0, the function is sin x by x, right? For x less than 0, the function is sin x by x. We know that sine function is continuous and x is also continuous. Okay, x is nothing but the polynomial function. So here it is quotient of two polynomial functions, that is polynomial. Sorry, that is continuous function. Quotient of two continuous function is also a continuous function. Okay, so for x less than 0, f of x is equal to sin x by x is continuous function. Okay, and for x greater than 0, it is a polynomial function and it is continuous. Okay, therefore for x less than 0 and x greater than 0, f of x is continuous. Why? For x less than 0, sin x divided by x is quotient of two continuous functions. Quotient of two continuous functions is also a continuous function. Okay, And for x greater than 0, x plus 1, I will write separately, okay? F of x is equal to, for x less than 0, okay, f of x is equal to sin x divided by x, that is quotient of two continuous functions. Hence, f of x is continuous at x less than 1. Next, x greater than, sorry, not x less than 1, x less than 0, okay, x less than 0. So, next is, for x greater than 0, f of x is equal to x plus 1 is polynomial function, and we know that every polynomial function is a continuous, hence f of x is continuous at x greater than 0. Okay. Now what about at x is equal to 0? That we have to find. So here at x is equal to 0. Here also, here we need to find, we need to check the left hand limit and right hand limit of the function at x is equal to 0. Okay. So limit x tends to 0 minus f of x. X tends to 0 minus, that means x less than 0. When x less than 0, the function is limit x tends to 0 minus sin x divided by x. Right? Here, see, limit x tends to 0 sin x divided by x. In our limit chapter, we have learned some standard limits, right? See here, limit x tends to 0 sin x divided by x. Some standard formulas we have learned. That is limit x tends to 0 sin x divided by x, that is equal to 1. Okay, in limits chapter, in class 11 limits chapter, we have already learned it. So limit x tends to 0 minus sin x by x. 0 minus means x approaching to 0, right? Approaching to 0, less than 0 or greater than 0, the value is 1. Okay. Okay. Then next, let's find right hand limit. Limit x tends to 0 plus f of x, that is equal to limit x tends to 0 plus f of x. 0 plus means x greater than 0. When x greater than 0, the function is x plus 1. Here substitute x is equal to 0, we will get 1. Okay. So left hand limit is equal to right hand limit. Next, one more thing we have to find, that is value of the function, that is f of 0. What is f of 0? F of 0 means at x is equal to 0, right? At x is equal to 0. See, when x is equal to 0, the function is x plus 1. Okay, f of x is equal to, at x is equal to 0, f of x is equal to x plus 1. So what is f of 0? Substitute x is equal to 0, that is 1. Okay, and so limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x, that is equal to f of 0. Therefore, according to the definition of the continuous function, this function is continuous at x is equal to 0. So this function is continuous at all the points, right? So this function has no point of discontinuity. Okay, because this function is continuous at all the points. So hence it is continuous at x is equal to 0. Okay. Hence this f of x has no point of discontinuity. Okay. F of x has no point of discontinuity because this function is continuous at all the points. Determine if f defined by f of x is equal to x square into sin 1 by x if x not equal to 0. F of x is equal to 0 if x is equal to 0. See here, very easy, is a continuous function. Okay, we have to determine this continuous function. Okay, or not. So here, first of all, if x not equal to 0, if x not equal to 0, we know that x square is a continuous function and sine 1 by x is also a continuous function. Why? Because sine function is a continuous function, right? So sine 1 by x is also a continuous function. So x square into sine 1 by x, that is product of two continuous function, is a continuous function, right? That is f of x is equal to x square into sine 1 by x is product of two continuous functions hence f of x is continuous at x not equal to 0. Okay. Then what about when x is equal to 0? See here, when x is equal to 0, the function is 0. When x is equal to 0, the function is 0. Function is 0 means it's a constant function. Constant function is always a continuous function. So here also we can write for x is equal to 0, f of x is equal to 0 is also a continuous function. Continuous function. Therefore, this function f of x is continuous, is a continuous function. Okay, because it is continuous at all the points. Okay, it is continuous at x is not equal to 0, x is equal to 0. Okay, therefore this given function is continuous. Find the value of k so that the function f is continuous at x is equal to 2. The function is f of x is equal to k x square if x less than or equal to 2. F of x is equal to 3 if x is greater than 2. Very important question, 2012 question. Okay. So here we have to find the value of k when this function is continuous at x is equal to 2. Okay. So here let's find the left hand limit and right hand limit of the function at x is equal to 2. Limit x tends to 2 minus f of x, that is equal to limit x tends to 2 minus f of x. X tends to 2 minus means x less than 2. The f of x is kx square, that is equal to, substitute x is equal to 2, that is 4k. Okay. So limit x tends to 2 plus f of x, that is equal to limit x tends to 2 plus, here 2 plus means x greater than 2, the function is 3. So limit of this 3 is 3 itself. And if this function is continuous at x is equal to 2, okay, if it is continuous at x is equal to 2, this left hand limit and right hand limit are equal, right? So here limit we can write, since f of x is continuous at x is equal to 2, limit x tends to 2 minus f of x, that is equal to limit x tends to 2 plus f of x, right? That is 4k is equal to 3, that implies k is equal to 3 by 4, that's all. Value of k is 3 by 4 if the function is continuous at x is equal to 2. Similar question, find the value of k so that the function f is continuous at x is equal to pi. The given function is f of x is equal to kx plus 1 if x less than or equal to pi. F of x is equal to cos x if x is greater than pi. Here also let's find left hand limit and right hand limit of the function at x is equal to pi. Okay. Limit x tends to pi minus f of x, that is equal to limit x tends to pi minus, pi minus means x less than pi, the function is kx plus 1 and substitute x is equal to pi, so k pi plus 1, right? Next, right hand limit, limit x tends to pi plus f of x, that is equal to limit x tends to pi plus means greater than pi, x greater than pi, function is cos x, so cos pi, substitute x is equal to pi, so cos pi is minus 1. And what is f of pi? F of pi is equal to, that is x is equal to pi. When x is equal to pi, kx plus 1, f of x is equal to kx plus 1, f of pi is k pi plus 1, k pi plus 1. Okay. So since it is continuous at x is equal to pi, since f is continuous at x is equal to pi, these are equal, right? Therefore, k pi plus 1 is equal to minus 1. That implies here we need to find the value of k, right? If it is continuous at x is equal to pi, means this left hand limit is equal to right hand limit is equal to value of the function. We can take any of these, okay, to find the value of k. So k pi plus 1 is equal to minus 1. That implies k pi is equal to minus 2. That implies k is equal to minus 2 by pi. That is the value of k when given function is continuous at x is equal to pi. Find the values of a and b such that the function defined by f of x is equal to 5 if x less than or equal to 2, f of x is equal to ax plus b if 2 less than x less than 10, f of x is equal to 21 if x greater than 10 is a continuous function. It's very important question, 2015 question. So here we have to find the values of a and b if the function is continuous function. And here we know that when x is less than 2, the function is continuous. And in the interval 2 to 10, the function is continuous. Right? Ax plus b is a polynomial function, it is also continuous. And when x is greater than 10, function is constant function, it is also continuous. So individually we can find the function, we can check the function, continuity of the function at x is equal to 2 and 10. Okay. Let's check x is equal to 2. Okay. At x is equal to 2, let's check the continuity of the function. Okay. So here it is given, it is if it is a function, then what is the value of x? Sorry, what is the value of a and b? So here let's find the left hand limit and right hand limit at x is equal to 2 and right hand limit and left hand limit at x is equal to 10. Okay. Okay, let's find. Limit x tends to 2 minus f of x, that is equal to limit x tends to 2 minus means x less than 2, the function is 5, limit is also 5. And limit x tends to 2 plus f of x is equal to limit x tends to 2 plus means greater than 2, greater than x greater than 2, here x greater than 2, the function is ax plus b, ax plus b. Substitute here x is equal to 2, so 2a plus b. Okay, we get 2a plus b. Next here, okay, then after that let's find. Okay, before that, see here it is given that if it is a continuous function, we have to find the value of a and b, right? If it is continuous, then these left hand limit and right hand limit should be equal, right? So here we can write since f is continuous, okay, this left hand limit and right hand limit are equal, that means 2a plus b is equal to 5. Okay, because it is given if it is a continuous function, what is the value of a and b? If it is a continuous function, it is a continuous function means it should be continuous at all the points. Okay, so at x is equal to 2 also it should be continuous. Okay, so here if it is continuous at x is equal to 2, this left hand limit and right hand limit are equal. Okay, therefore 2a plus b is equal to 5. We have got one equation. Okay, next we will get another equation. Then by solving these two, we will get a and b values. Okay, so next at x is equal to 10. Okay, it is at x is equal to 2. At x is equal to 10. Okay, let's check the continuity at x is equal to 10. Limit x tends to 10 minus f of x is equal to limit x tends to 10 minus f of x. 10 minus means x less than 10. X less than 10 ax plus b. Okay, function is x plus b. Here substitute x is equal to 10. So limit is 10x plus b. Okay. Sorry, 10a plus b. Okay, 10a plus b. Next, right hand limit. Limit x tends to 10 plus f of x, that is equal to limit x tends to 10 plus. 10 plus means x greater than 10. When x greater than 10, f of x is equal to 21. The value is 21. Okay. So here also, since it is a continuous function, since f is continuous function, this function is continuous at x is equal to 10. If it is continuous at x is equal to 10, this left hand limit and right hand limit of the function at x is equal to 10 are equal, right? Therefore, here we can write, since f is continuous, ten a plus b is equal to 21. Okay, this should be equal. So we have got two equations of unknown with unknown a and b. Okay, so here we can find the values of a and b. See, subtract equation 1 from 2. Okay, equation 1 minus equation 2 minus equation 1. Okay, you can do 1 minus 2, whatever, you will get the same answer. Okay, so 10a minus 2a, 8a, b cancelled, that is equal to 21 minus 5, that is 16. This implies a is equal to 16 by 8, a is equal to 2. If a is equal to 2, substitute this a is equal to 2 in any of these equations, you will get the value of b. That is, equation 1 gives 2 into 2, 4. 4 plus b is equal to 5. This implies b is equal to 1. Okay, so we have got a is equal to 2 and b is equal to 1. Okay. Show that the function defined by f of x is equal to modulus cos x is a continuous function. Modulus cos x. So here let us take two different functions and take its composite. Okay, here let g of x is equal to cos x and h of x is equal to modulus x. And we know that cos x, cosine function is a continuous function, and modulus x is also a continuous function. Okay, so here what is h composite g of x? That is h of g of x, right? What is g of x? Cos x, right? So h of g of x. G of x is cos x. So h of x is nothing but modulus x. So in place of x we have to put cos x, right? That is h of g of x. So modulus cos x. Okay. So here g of x and h of x are continuous. G of x and h of x are continuous. Therefore, h composite g of x is also continuous. Continuous function. Okay. Find all the point of discontinuity of f defined by f of x is equal to modulus x minus modulus x plus 1. Okay, so here given function f of x is equal to modulus x minus modulus x plus 1. Here modulus x is a continuous function, right? And here we have to check the continuity of the modulus x plus 1. Okay, for that here we will take two functions and combine it. Combining means composite functions. Okay, so here we have to take two functions. Let g of x is equal to modulus x and h of x is equal to x plus 1. Okay, here we have to take two functions when this combined function means composite function will be x plus 1. Okay, according to that we have to take the two functions. Okay, that is g of x is equal to modulus x, h of x is equal to x plus 1. So when you take h composite g of x, so it will be, you just check it, h composite g means h of g of x. Okay, h of g of x. What is g of x? G of x is modulus x. Okay, so h of x is x plus 1. So just to put when in replace x to x plus 1, right? So it will be modulus x plus 1, right? Okay, h composite g of x is equal to h of g of x, that is equal to modulus x plus 1. Here h of x is equal to, g of x is equal to modulus x and h of x is equal to x plus 1. Okay, so here we will write, see, g of h of x. What is g of h of x? G of h of x is x plus 1. Okay, now here we will find g of x plus 1. G of x is modulus x. So substitute x plus 1, that is modulus x plus 1. Okay, now what is h composite g? H composite g of x is h of g of x. Okay, that is h of g of x is modulus x. Okay, modulus x. And h of x is x plus 1. So it will be modulus x plus 1, right? So here we have to find, we need to check the continuity of modulus x plus 1, right? So here we will take g composite h, not h composite g composite h. Okay, because we need to find the, we need this modulus x plus 1, not modulus x plus 1. Okay, so here we have got g composite h of x is equal to modulus x plus 1. Okay, so here g of x modulus x, h of x plus 1. Modulus x is a continuous function, x plus 1 is also a continuous function, right? That is a polynomial function. It is a continuous function. Therefore, its composite function, that is g composite h and h composite g are also continuous function. Therefore, modulus x plus 1 is also a continuous function. So, therefore, x plus 1 is a continuous function, right? Because algebra of continuous functions, see, g of x and h of x are continuous function, then g composite h is also continuous function. Therefore, modulus x plus 1 is a continuous function. Okay, here what is our function? F of x is equal to modulus x minus modulus x plus 1, right? Right, here modulus x is a continuous function and modulus x plus 1 is a continuous function. Therefore, their subtraction, that is difference of continuous function, is also a continuous function. We studied in algebra of continuous functions, right? That is, if f and g are continuous function, then f minus g is also a continuous function. Therefore, modulus x minus modulus x plus 1 is a continuous function. So here we have got this function is a continuous function at all the points. Here domain is nothing but domain of this function is R. Okay, that is set of real numbers. So this function is continuous in all the domain. Okay, all the elements of the domain. Therefore, this function has no point of discontinuity. Okay, here actually our question is find all the point of discontinuity of this function, right? But here this function is continuous at all the points. Therefore, this function has no point of discontinuity. F of x has no point of discontinuity.